If you've spent any time at all in the world of AI, you've probably heard this mantra a million times. More data is always better. The bigger your data set, the smarter your model gets. It's kind of the number one rule of the big data era. But is it really that simple? Is the answer to every problem just to throw more and more information at it? Well, today we're going to dig into that exact question, and we're going to see why that common piece of advice might not be the whole story. So, first off, let's talk about why this idea is so popular. It's what we can call the more data promise. And honestly, on the surface, it makes perfect sense. I mean, it's a really compelling idea, isn't it? The logic seems so straightforward. If you want to teach a model to recognize cats, just show it more cat photos. If you want to predict sales, feed it more sales data. But hidden inside this simple idea is a really, really important catch. And that catch brings us right to the first major problem you can hit when you just blindly chase after more data. It's a classic pitfall in machine learning, and it's called the overfitting trap. Okay, here is a great way to think about it. Imagine a student who's studying for a big test, but instead of actually learning the concepts, they just decide to memorize the entire textbook. I mean, word for word, they know the page numbers, they even know where the typos are. Now, they could tell you exactly what's on page 243, but what happens if they get a new question they've never seen before, one that needs them to apply what they've learned? They'd fail completely. Why? Because they didn't really learn, they just memorized. And that is exactly what we mean by overfitting. The model becomes so perfectly tuned to the specific data it was trained on that it just loses the ability to generalize. It can't handle new, unseen data. So what's the result? It looks amazing on its training set, but it's totally useless when it bumps into something new out in the real world. If you try to picture this, a good model is like a nice, smooth curve that captures the general trend in the data. But an overfitted model, it's like this crazy, frantic, squiggly line that twists and turns to hit every single data point. In its desperate attempt to be perfect, it ends up capturing all the random junk, the noise, instead of the actual pattern, the signal. So this chart does a great job of laying out what's called the bias-variance trade-off. On one hand, you have an underfitted model. It's just too simple. It has high bias, which basically means it's consistently wrong because it's completely missing the pattern. On the other hand, you have an overfitted model. This one is way too complex. It has high variance, meaning its predictions are all over the place because it's memorized all that random noise. The real goal, that sweet spot, is finding a model right in the middle. So, we've mentioned a few times that an overfitted model captures noise. But what does that word even mean when we're talking about a data set? Let's get into our next big idea, the problem with noise. You can think about it like static on a radio. You're trying to listen to your favorite song, that's the signal. But all you can hear is that awful hissing sound. That's the noise. For a machine learning model, that static isn't just a distraction. It's actually teaching the model the wrong things. And that leads it to make really bad predictions. And this noise, well, it can sneak in from anywhere. It might be tiny errors from your measurement tools. It could be simple human error, like someone accidentally labeling a picture of a dog as a cat. Sometimes you have outliers, these really extreme data points that just don't belong. But one of the biggest culprits is just including totally irrelevant features, like trying to predict stock prices using a CEO's shoe size. Sure, it's data, but for this particular problem, it's just meaningless noise. Let's circle back to our student analogy for a second. Giving a model noisy data is exactly like asking our student to study from a textbook that's just full of typos and factual errors. No matter how hard they try to memorize it, they're learning the wrong stuff from the very beginning. Their performance is going to suffer because the source material itself was just bad. So, not only can more data sometimes lead to worse models, but this obsession with just getting more and more comes with some very real practical problems. Let's talk about the hidden costs. The reality is, working with huge datasets isn't free. In fact, it can be incredibly expensive. For one, it means much longer training times, since the computer has to process more and more info. It also means you need more memory and storage, which costs real money. And all of that extra computing power uses a lot more energy. These are the practical costs that often get forgotten in the big race for more data. Okay, so if piling on more data isn't the magic solution, then what is? Well, that brings us to the core message of this whole thing. It's all about focusing on quality over quantity. This quote here really just nails it. A model's performance doesn't just come down to the sheer amount of data. What really matters is how relevant that data is, how clean it is, and whether it actually represents the problem you're trying to solve. In short, it all comes down to quality.
So how do you focus on quality?
Well, it comes down to 3 key steps. First, you have to clean the data. That means actively getting in there, removing the noise, fixing errors, and dealing with those outliers. Second, you practice smart feature selection. You choose only the most important information for your model to learn from, and you throw out the irrelevant stuff like the shoe sizes. And third, you make sure your data is a representative sample that actually looks like the real-world problem you want to solve. So, let's wrap all of this up with one simple, powerful idea. The goal in machine learning is not to have the most data. It's to have the best data. A smaller, cleaner, more relevant data set will almost always build a better, more reliable model than a massive, messy, unfocused one will. And that leaves us with one last question for you to think about. The next time you're working on a problem and your first instinct is, I need more data, just pause for a second. Ask yourself this: have I taken a close enough look at the quality of the data I already have? The breakthrough you're looking for might just be right there.